All right, so we're gonna pick up where we left off. We're gonna so open up your books to page 36, um, and we're gonna do problem number 10. I'm gonna do it with you because I think um, sometimes it helps. The best way to learn how to do math is to do a lot of it. So we're just gonna do a lot of it together, and then I'm gonna give you some problems to do on your own. So if I say 4, did we do problem number 10? No, we stopped at 9, right? 1 through 9. All right. So now this is guided practice in your textbook. So they have this little thing in your book. What do I put there in the box? Oh, there's 3 fours. Really should look and pay attention, huh? All right. So, oh, hey, you're right. So what do I put in the box then if I have this? Yeah, because I'm multiplying 4 by itself 3 times, so I'm going to put the 3 there. Well, bam, with the bacon sizzle. It's like you guys know what you're doing. You must have an amazing math teacher. You did last year? Nice, nice. All right, shh, be quiet. So now we're going to do, remember I'm recording, 2 times 2 times 2 times 2 times 2. Right here I have 1, 2 twos, and then over here I have 1, 2, 3 twos. And then in your textbook, it wants me to write it like this: 2 raised to a certain power times 2 raised to a certain power. So I'm going to put a 2 here and a 3 here. And then it wants me to say 2 raised to something all by itself. So how many 2's do I have total? 5. So what I want you to do is when you see a problem like this, the problem, you guys are going to get these 2 rules confused, okay? You're supposed to add the powers, right? In other words, 2 plus 3 equals 5. But when you raise a power to a power, you multiply the powers. And somebody's going to make the mistake. If you can't remember what to do, just write it out. And when you write it out and count them, you'll see, oh, yeah, I multiply, or oh, yeah, I add them. Okay? So let's move on to problem number 12. I've got 6. Ooh, that's not a good 6. 6 to the 7th over 6 to the 5th. And in your textbook, they write out 1, 2, 3, 4, 5, 6, 7 sixes. Right? Because 6 to the 7th power means you're multiplying 6 by itself 7 times. And then on the bottom, they have 1, 2, 3. I feel like the count on Sesame Street. 1, 6, 2, 3, 4. Anyways, there's 5 of those bad boys. Now, what is 6 divided by 6, though? 1. What is 6 divided by 6? 1. 6 divided by 6? 1. So we could do that for every one of these. And we're basically reducing. So I've got 1 times 1 times 1 times 1. How many 6's on the top? So I'm going to write this a little different than your book. I'm going to have 6 times 6 on the top. And I've got 1 times 1 times 1 times 1 all over 1. What's 6 times 6?
36.
Well, but your textbook just wants us to write the power. So how do I write that in the exponent form? 6 squared, right? Now, I want you to think this. You may not remember this, but I want you to think this. This is the same as saying 6 to the 7 minus 5, right? So when we're dividing, this is what you're going to write down in the book. This is your answer. But I want you to think this. This is the shortcut. Okay? You take that bottom power and subtract it from the top. Consequently, you could subtract the top from the bottom as long as you keep track of it. Okay? So one little thing that Mr. Adams does once we get going with this, you'll see that when we start doing algebra problems, I'll do this little deal where I say minus 5, minus 5. We'll talk more about that later. Okay? Anyways, let's move on to problem number 13. We have 8 to the 12 all over 8 to the 9. Now, I'm not going to write this out. I want you to do this, though. Say 8, and then they write it like this. Something minus something. What goes in this box? 12, right? What goes in this box? 9. So then it says 8 raised to the, what's 12 minus 9? 3. Well, bam with the bacon sizzle. We're almost done with this section. I've got 5 to the 10. Now, this is a tricky one. Oh, wait. I'm getting ahead of myself. 5 to the 10 times 5 equals 5 raised to the something. When I just have a 5, isn't that the same as 5 raised to the first power? Yes. Isn't that the same as 5 to the first power? Yes. So what's 10 plus 1 plus 1? 12. Or if you grew up where I grew up, 12. Let's move on to problem number 15. Problem number 15, more of the same. 7 to the 8th power times 7 to the 5th power is equal to 7. Yep, 8 plus 5 is 13. Almost done. 16. Now this is an interesting one. We have 6 squared raised to the 4th power. So in this particular case, we have a power raised to a power. Okay, we have a power raised to a power. So, what's 6 squared?
36.
Well, yeah, but it's the same as 6 times 6. Follow what we have on page 36, okay? So it's 6 times 6 raised to the 4th power. So now that would be, this is a little tricky. That would be 6 times 6. How many times? 4 times, right? Because we're raising it to the 4th power. So I've got 1, 2, 3, 4. What am I raising to the 4th power? 6 times 6. Right? All right. Whew, that's a lot of stuff. I'm running out of room. So then the next step, I have 6 raised to the, how many 6s do I have? 1, 2, 3, 4, 5, 6, 7, 8. But what's 2 times 4? 8. Well, bam with the bacon sizzle. Why am I saying that? Because I do what I want. Oh, we can't say names. Oh shoot, I don't want to. Well, we've got one more problem, and then we'll move on to the next thing. Oh wait, did you guys get that copied? All right, real quick, get it copied. All right, I'm gonna pause the video, and we'll do the rest in the next video. Well, bam with the bacon sizzle. That's one of my professors